Hi, my name is Greg, and today I wanted to build on the idea that we previously discovered on the idea of molecular mass, but I kind of wanted to take it backwards. So what I showed you last time is that being given a molecule, you can work out its molecular mass, and also obviously you'll need the atomic masses of all the constituent atoms. But what I wanted to show you today is if we were given some sort of molecule, and we don't really know how many atoms of something there are in this molecule, but if we know its molecular mass, then I'm going to show you how to actually work back and actually find how many molecules are in here. So an easy way to do this question, as you can see, I've got some sort of compound containing gallium and 3 oxygens, but I don't know how many galliums there are. I do know that the molecular mass of the compound is 187.44 units, and I know that the atomic masses of gallium and oxygen are respectively 69.72 units and 16.00 units. So what I could do first is I could take away my 3 oxygens. So I could take my 187.44 units and I could subtract 3 oxygens. And what this gets me, if I just quickly do this on a calculator, is this gets me 139.44 units. Now I know I've got some amount of gallium, and I know each gallium is actually 69.72 units. So if I take 139.44 and I divide it by its atomic mass, which is 69.72, and this should by all means get me 2, if I remember correctly, but I will check. And it gets me exactly 2, hence X is equal to 2. And what I can say here is that this compound is just gallium oxide, so Ga2O3. Let's try another example, and by all means feel free to have a go at it yourself on your own before you see my answer to it. So this time I've got some sort of compound containing nitrogen, 2 nitrogens, and some amount of oxygen, and I know it's got a molecular mass of 76.02 units. I know that each nitrogen has an atomic mass of 14.01 units, and each oxygen has an atomic mass of 16 units. So what can I do here? Well, I could take away the 2 nitrogens that I know, so I could take my molecular mass of 76.02 units, and I could take away 2 times 14.01 units of the nitrogen. And hence, what this would get me something like 48 units. Now, I don't know how many oxygens I've got, but I know each oxygen has an atomic mass of exactly 16. So if I take my 48 units, I divide it by my 16.00 units, what I'll get is I'll get the number of oxygens, which is 3. So this compound is N2O3, which we call nitrogen trioxide, or sometimes called dinitrogen trioxide. So this would be most likely dinitrogen trioxide. Let's try one more. And again, feel free to have a go at it yourself before you see my model answer here. So, what do we know? We know that the molecular mass of this compound containing 2 hydrogens, 2 sulfurs, and some amount of oxygens is 114.16 units. So know that the atomic mass of hydrogen is 1.01 units, the atomic mass of sulfur is 32.07 units, and the atomic mass of oxygen is still 16.00 units. So what can we do? Well, I can take away the hydrogen and sulfurs that I know, and I'll just be left with the total mass of the oxygens, right? So I could take my 114.16 units, I can take away 2 times the hydrogens that I've got, so that's 1.01 units, and I can take away 2 times my sulfurs, which is 32.07 units. And what I'll hopefully be left with is something like 48 units. If you take 48 units again, and divide it by your... So this is just the total oxygen. If I divide it by 1 oxygen, what I'll get is how many oxygens I've got, which is 3. So the compound that we're talking about is H2S2O3, commonly known as thiosulfuric acid. Okay, let's try the very last question. So this is pretty much as difficult as it gets. We've got no knowledge about how many carbons, hydrogens, or oxygens I've got in this compound. Okay, so again, feel free to have a go at it yourself before I do it. Okay, hopefully you've kind of tried it, gotten maybe some sort of ideas. So what can we do here? Well, I do know that each carbon is 12.01 units. So I could take my X and multiply it by 12.01 units. And if I add to that 2x, which I know is, well, that's how much hydrogen I've got, and I multiply it by just the atomic mass of hydrogen, 1.01 units, and to that I also do add the oxygen, which is just X times 16 units, or 16.00 units. This I know must be equal to 180.18 units. So let's see how far we can go with this algebraically. Well, I know that I've got 12.01x plus 2.02x plus 16x. So what does this add up to? Well, 2.02 add 12.01 add 16 adds up to, and this is still equal to 180.18 units, by the way, 180.18 units. This adds up to 30.03x, still equal to 180.18 units. Now, if I was to divide through by 30.03, I'll get x equals, which is pretty much what I'm hoping for here. So 180.18 divided by 30.03 gets me 6. Hence, x is 6. But I also need to know what 2x is. 2x, I know, is 12. Going back to my formula, if I know that x is 6 and 2x is 12, I can work out what kind of compound this is. So this could be C6, H12, O6, which looks like glucose to me.